Joe can paint a house in 3 hours, and Sam can paint the same house in 5 hours. How long does it take for them to do it together?
Wait a minute. You never said this was a word problem.
A word problem? Yes, we like to solve word problems, right? So in this case, Bill can paint the house in 5 hours, Mary can paint the house in 3 hours, and the question is, how long will it take them to paint the house if they work together? So one of the things I'd like to point out, in case you were to use this problem in your own classroom, is sometimes students learn to look for key words, and those key words tell them what they should do. And in this case, they might see the key word of together. And of course, together means add, and so students will just add 5 hours plus 3 hours and get 8 hours. But when you really think about that, it doesn't make much sense. If Mary can do the whole job in 3 hours, working together, assuming no other weird things are going on, that they should be able to do it in faster than 3 hours. So 8 hours just doesn't make any sense. So I encourage you not to focus on those kinds of key words. You know, together always means add, because it doesn't always mean add. Instead, let's look at this from the point of view of fractions. So Bill paints 1/5 of the house in 1/5 of the time. And I'd like to just highlight for you as teachers that what we're getting at here is there's a proportional correspondence here. 1/5 of the house, 1/5 of the time. 1/3 of the house, 1/3 of the time. So Bill paints 1/5 of the house in 1/5 of the 5-hour time, or 1 hour, and Mary paints 1/3 of the house in 1/3 of her time, 3 hours, or also 1 hour. And so together, first separately, Bill paints 1/5 of the house in an hour, Mary paints 1/3 of the house in an hour, and so together, now here's where addition can come in. Together, Bill paints 1/5 of the house, Mary paints 1/3 of the house, and so together, what part of the house do they paint? So I'd like to also pause here because when on the Saturday workshop I had said, if you're going to teach adding fractions, don't teach adding fractions. And what I meant by that was, don't just launch into an algorithm for teaching adding fractions. Maybe use a scenario, maybe not this one to start with, but maybe use a scenario where addition of fractions is needed and let students solve the problem. Let them persevere. Let them make sense of the problem. Let them use appropriate tools. Let them engage in the standards for mathematical practices. All right, so we could use the fraction pieces to help us model this particular setting here. So here in the green, we can think about Bill. Bill paints the whole house in 5 hours. 1, 2, 3, 4, 5. And so he paints 1/5 of the house in an hour. So this is one copy of 1/5, where 1/5 is what we get if we take the whole and cut it up into 5 equal parts. In this case, each of those parts is 1 whole hour. Likewise for Mary. Mary paints the whole house in 3 hours. So in 1 hour, she paints 1/3 of the house, where 1/3 is what we would get if we took the whole, cut it up into 3 equal pieces. So this is 1/3 of the house in 1 hour. This is 1/5 of the house in 1 hour, and we want to add them together to see how long it would take them to paint the house if they work together. So visually we can see it's nearly a half. They can paint about half of the house if they work together in an hour. But how much is it exactly? And what I want students to struggle with at this moment is, well, how can we add these quantities together when one of them is 1/5 and one of them is 1/3? Well, as we think through this, and remember, these are students who have been making sense of fractions in multiple ways, and so this is not going to be a stretch for them to think about taking this 1/5 and cutting it up into 3 pieces, taking this 1/3 and cutting it up into 5 pieces. And so if you went back to the wholes, if I cut each of these up into 3, there'd be 15. If I cut each of these up into 5, there'd be 15. And so together, what do we have when we put these together? And so that's how I want the students to be thinking. I want them to come up with a way of how can we add 1/5 and 1/3 so that we can actually figure out how much do we have when we put those together. So this is not going to happen quickly, I want the students to struggle and work through this to make sense of it, but ultimately I want them to figure out that this 1/5 piece that represents how much of the house Bill paints in an hour needed to be cut up into 3 equal pieces, along with all the other 1/5s, so that it becomes a 3/15. And likewise, this 1/3 piece needs to be cut up into 5 equal pieces, along with all the other 1/3s, so that it's a 5/15. And what I've seen with students is when they think about fraction in this multiplicative way, and they think this is 3 copies of a 1/15, where 1/15 is what you get if you take a whole and cut it up into 15 equal parts. And this is 5 copies of a 1/15. Well, when we push that together, 3 1/15 and 5 1/15, you can just imagine you have 8 1/15. You have 8 copies of 1/15, 8/15. And so what we now know is together in 1 hour, Bill and Mary can paint 8/15 of the house in 1 hour. So at this stage, many folks on the Saturday workshop and students, as they're thinking through this, will think about this. If you can paint, or together, Bill and Mary can paint 8/15 of the house in 1 hour, well then in 2 hours, if you double the time, you'll double how much of the house they paint. That would be 16/15 of the house. Well, that's more than the whole house. So what does that tell us about how long it's going to take if they work together? Well, they can do it then in less than 2 hours. But we have to figure out exactly how much less than 2 hours can they do it. And this is where this tape diagram idea becomes really useful, I think. And so let's just build a model of what this might look like. So let's pretend this represents painting the house in so much time. And so we're going to break this up into the 15 parts. So 1, 2, 3, 5, 6, 7, 8, 9, 10. Let me see what I got here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Pretend all of those are equally sized pieces. So what we found out was Bill and Mary can paint 8/15 of the house. So there's 3, 4, 5, 6, 7, and 8. Bill and Mary can paint 8/15 of the house in 1 hour. So the entire rectangle is 15/15 of the house. The whole house has been painted. We know 8/15 of the house can be painted in 1 hour. The question is, how long is it going to take them to paint this other 7/15? So let's take a look at this. Here's 1, 2, 3, 4, 5, 6, and 7. So the question is, this remaining 7/15 of the house can be painted in how much time? Well, this is where I think things get really interesting in terms of how we are to think about fractions. You know, thinking about them as in terms of cutting and copying, keeping track of what represents one whole, all those important things all come together right here. Because here's where a useful way of thinking emerges. So here in blue, we have 8/15 of the house, which is equivalent to 1 hour's worth of time in terms of the work. So what if we now look at what's in blue as one whole hour? That 1 whole hour could be cut up into 1, 2, 3, 4, 5, 6, 7, 8 pieces. So how big would each piece be? Well, if you took 1 whole hour, or 60 minutes, and cut it up or divided it into 1, 2, 3, 4, 5, 6, 7, 8 pieces, 60 minutes divided by 8 comes out to be 7.5 minutes per piece. So this is 7.5 minutes, this is 7.5 minutes, this is 7.5 minutes, etc. Each one of those is 7.5 minutes. And 8 7.5 minutes is 1 hour, which is 1/15 of the house. Now, if we continue that over here then this is 7.5 minutes, this is 7.5 minutes. Each one of these is also 7.5 minutes. And what we have here, the remaining 7/15 of the house, is we have 7 copies of those 7.5 minutes. So to figure out the time, we could just say we have 7 copies of 7.5 minutes, which comes out to be 52.5 minutes. So the 7/15 of the house can be painted in 52.5 minutes. So altogether, 8/15 of the house got painted in an hour. 7/15, the remaining 7/15 of the house gets painted in 52.5 minutes. So working together, Bill and Mary can paint the house in 1 hour and 52.5 minutes. So what I love about this is looking at what fractions are. We're cutting and copying. We've got the tape diagram model to make sense of our thinking. It's a tool to help us to think through this. And as students solve problems like this over and over and over again, thinking about number 8 on the poster, this repeated reasoning, well then this tool becomes a go-to. It becomes something that they will use readily. Now another way that you might look at this that I think is helpful is if we think about this chunk in blue as representing 1 whole hour rather than 8/15 of a house, think of this as representing 1 whole hour. So 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8 is 1 whole hour. Then we have an additional 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8 of an hour. And so the whole house could be painted in 1 7/8 hours. Now you could represent that so many ways. 8/8 and 7/8 is 15/8 hours. You could say that. And then this is where you saw in the video the craziness where the one guy comes in and he says, I know how to solve this problem. All you have to do is do this. Bill can paint the house in 5. Mary can paint the house in 3. So you multiply 5 times 3. And you divide that by Bill can paint the house in 5. Mary can paint the house in 3. You add 5 times 3 is 15. 5 plus 3 is 8. And little Billy, I think that's his name, says, oh, that's how you do it. Great. And they move on. And I just think that's how our traditional education has been, is to just show formulas to get answers. And if you look back at all of this, the reasoning behind where something like that comes from is really where things get powerful. The thinking gets interesting, and we develop really powerful ways of thinking with our students.